Okay, let's get started. Okay, so we're on to the next problem set, which is problem set 10. That has been posted. I made the due date Monday for several reasons, but anyway, so you have the weekend to work on it if you need it. It involves creating a graphical user interface, and we'll talk some more about graphical user interfaces today. I've also posted sort of a skeleton for the final project. Essentially, you can see what the due dates are going to be. I don't have the actual problem here yet. The first due date is the Wednesday before Thanksgiving, which is just a week from this coming Wednesday. And by that day, you need to have decided who your partner is going to be. If partnership is optional, so you can work by yourself if you wish. You can work with a partner if you wish. Either way, you've got to do something to let us know what your choice was. Essentially, you've got to create a team, either a one-person team or a two-person team. And so that's PS 11A, so be sure you look at that before Thanksgiving. Any problems, questions, issues we can deal with here? Yeah?
For PS10, is there any guidance on when we should be throwing exceptions, or is that just up to our own judgment?
You're asking for problem set 10 guidance on when you should be throwing exceptions.
Yeah, because for Connect 4, there you had a different criteria of when we should be throwing exceptions, but I'm not sure when to do that for this one, or is that just kind of up to our own judgment?
I mean, so first of all, you shouldn't be, ultimately, your application should not be throwing exceptions. It should, any exceptions get thrown, it should catch and deal with.
Okay.
You know, when I designed the API, which may be what you're thinking about, the API you implemented, you implemented the class that kept track of the state of the Connect 4 game. And I just had to decide what happens if the parameters make no sense. And I do that by throwing exceptions. Now, it turned out that my GUI never never made a method call that had garbled parameters, and so the exceptions aren't thrown.
Okay.
But it's pretty standard to throw an exception when parameters aren't what you expect, when they violate constraints. Any other questions? Yes?
Do we need to worry about making it work outside of the 5x5 grid, like with sizes other than that, or should we just?
No, you just need to make it work in the 5x5 grid. Okay. All right, one thing I also want to point out is there's this challenge problem called CX. And the deal is you can do any challenge problem from anywhere in the Xi book that you haven't done already. And even if it's past you or wasn't even ever assigned. And I will count those challenge points that you get that way toward your challenge and or participation points at the end of the semester. So if you missed challenge points, that's an obvious way to make them up, just do them. Or if you miss participation points, extra challenge activities you do will apply toward participation points. But that has to be done by the last day of classes, which is 4 more weeks of classes left. Okay, I'm going to go to Eclipse now and talk about our goal for the next week and a half is to talk about polymorphism. And that means we'll be talking about things like interfaces, implementing interfaces. We'll be talking about inheritance. We'll be talking about abstract classes, which is a variation of inheritance. We'll be talking about typecasts in the context of polymorphism. So we'll be looking at a variety of examples that help drive all this stuff home. What I want to do is, at the first part of the day, is talk about the GUI part of the Connect 4 game and show you how that went together and how it exploits polymorphism. And this will also, beyond learning about polymorphism, it'll help you see how it goes together, so that will help you build your application coming up. So what we're looking at is the class c4board.java. Before I do that, let me just start it here. Okay, so there are, there's the board, and you're familiar with it. And it turns out there are 3 major classes that I created to help represent the board. There is the board itself, the whole application. So the whole window, that J-frame right there. There's a custom class to represent the whole thing. Then there's a custom class to represent this grid here, where you actually play the game. So that's the second class. And there's a third class whose objects are the individual circles here. So my program, in the end, it creates one of C4 display is the class that represents the J-frame. So it creates one of those objects. Inside that, it places this grid. And inside the grid, it places however many, 42 or something of these circle things there are, get placed inside of that. So these are all custom classes I created. And making them work involved exploiting inheritance. Yeah?
So one object's the J-frame that everything goes on, the other one's is it the grid?
Yes, the grid.
And then the third one is the dots that go in the grid?
Yeah. You can think of it as the circles that go in the grid. Really, it's the whole, a bunch of squares. There are 42 squares. Each square that makes up the grid is an object. Okay? So let's dig in and see. This is just the main method that you see whenever there's a GUI. That's just to bring up a GUI, you've got to create a new J-frame. That way. And I don't feel like explaining that today either, so I won't. Now here is the class called C4 display. And we haven't done much with this before. You know that when you create a new class, if it's a public class in a file, the file has to be named, in this case, c4display.java. But in addition to this class, as we scroll down, I have a second class called board. That's the grid. And I have a third class called square. And that's the 42 squares that make up the grid. So you can put more than one class in a file. You can't make them public, though. There can only be one public class in a file, and the file has to be named after that public class. You can put other non-public classes. Now, you might ask, why did I do that instead of making square public and making board public? Just, I guess, for variety's sake. Sometimes it's just simpler to have things in one file, but I easily could have made it with separate files. So let's look. So look here at the header. So what do you know right off the bat about a C4 display object? Because remember, back here, to run the application, we are creating a new C4 display. So what can you tell me about this C4 display class, or about C4 display objects in general? Yeah?
It's an extension of the J-frame class, so it's going to have all of J-frames.
Okay. So C4 display extends J-frame. It inherits from J-frame. And that means a couple of things. First of all, it means that any C4 display object is also a J-frame object. So anything that you can do, any method that you can invoke on a J-frame object, you can invoke on a C4 board, a C4 display object. Okay, because of that inheritance. Anywhere, any method that takes a J-frame, you can pass a C4 display. All right? If you have a method that's supposed to return a J-frame, you could return a C4 display. Yeah?
The same thing with the action listener. As if a method needs an action listener, we can give it the C4 display type.
Yeah, well, I'll get to the implements in a second, but that is true. So besides that, so there's a subtyping relationship. C4 display is a subtype of JFrame. We call JFrame the supertype, and we call C4 display the subtype, or the, well, subtype's good enough. It just means it can be used anywhere a JFrame can be used. But there's more to inheritance than that. Not only is a C4 display now a JFrame, A C4 display inherits all the methods, all the public and protected. We'll talk about protected methods another time. It's between private and public. But anyway, we inherit a bunch of methods. Any method that's not private, we inherit from C4 display. And of course, and that means that before we even write a spec of code, all you have to do is say public class C4 display extends JFrame, and boom, C4 display already has all the methods that were defined in JFrame. And of course, it has to be that way, or you couldn't use a C4 display where a JFrame is needed. It better inherit all those methods, or we wouldn't be able to use it that way. And then what we can do is we can add more methods beyond what's defined in JFrame, or we can replace some of the methods with JFrame with our own version. We can customize, override is the term that's used. We'll see examples of that going forward. So the C4 display object can be used, it is a JFrame object. Okay? So someone tell me, what does this tell us? Yeah. Let me back behind.
So it uses the interface action listener.
Okay, so action listener is an interface. So when we advertise up here that we are implementing action listener, what does that mean? Yep.
All the method, I guess, stubs that are in action listener will be fully implemented here.
Okay. So he's talking about method stubs. So remember, an interface, I mean, JFrame is a class. So it has a bunch of implemented methods that are inherited by C4 display. Action listener is an interface. It just has a list of method headers. It doesn't have any code. So when we say that we implement action listener, when we make that claim, we've got to make sure that we have implemented all the methods that are named in the interface. And the only method that's named in the interface, in that interface, is action performed. So somewhere down here, there better be an action performed listener. And here it is. So if I were to change the name of that, say I call it action performed X. Okay, suddenly, well, it's complaining because we're claiming right here to override a method. And you can only override a method if it exists in the interface. But now up here is an error. And what's that error going to be? Why does C4 display underline? Yeah?
Because it didn't implement action listener properly.
Right. It's our obligation to implement an action listener method, and we didn't. So if I hover the mouse, it says, the type C4 display must implement the inherited abstract method action performed. And it doesn't because I renamed it. So I'll go down here and undo all that. Now everybody's happy. So because we have implemented the interface, a C4 display object, in addition to being a kind of JFrame, is also a kind of action listener. So anywhere an action listener is needed, we can provide a C4 display object. And that'll work out because, you know, if we hand an action listener to someone, what can they do to it? What methods can be called on an action listener object? Yeah?
And then just action.
Action performed. And we got it covered. Right? Basically, we're saying by putting this up here, we're saying we have an action performed method that can be called. Okay, so that's good. Our C4 display can be used as either a JFrame or an action listener. These are just some constants I defined, you know, that control the size and the shape and the color of things. They're all final, so they're all constants. So I won't dwell on those. You can change them to change the look of things. And then there are various instance variables. What's that right there? Yeah?
It's a private C4 board object.
Well, it's a private C4 board object, sure. But where does that come from? What does it do? It says it's the smarts of the game. What is that thing? Yeah.
It's the class that we made that controls all the game mechanics.
Right. It's the class you implemented for PS, what was it, 9, 8? It understands the game. It knows the rules of the game. So it provides methods that let you run a game. And this separation is very deliberate on my part. In C4 display, I put all the details about how the game looks. And that's C4 display. Then in C4 board, I put all the methods that have to do with how the game works. So the rules of the game are built into C4 board. The look and feel is built into C4 display. And that separation is a common strategy for implementing graphical user interfaces. And I'd like you to try to follow it when you do your implementation for PS10. So concentrate on one class or collection of classes governing how it looks. Another class that governs the rules of the game. Yeah?
Why would you do it that way instead of extending the C4 class?
Oh, okay, you're asking why would I do what this way?
Well, I'm not sure, because like I'm not sure what you were gonna do with that, but like if you were looking to have, you said you have that so you know like that's like how you know how the game works. But why wouldn't you just extend C4 board then so you can have all the rules?
So in other words, why not just add the rules to C4 display?
Or just or just extend C4 board on C4 display.
Okay, I'm not sure what I'll riff on what you ask. I may not exactly answer your question. Let me just turn it into another question. Why the separation? Why is the separation a good idea in the first place? Why have one class that knows all about the rules but nothing about the user interface? Another one that knows about the user interface but nothing about the rules? Yeah.
You can have different implementations of that graphical interface.
Okay.
Separate, so you can do different things with that.
Right. So it may be, okay, you get the game working, that's great, and someone says, I'd like it to work on my phone. And maybe, you know, on a laptop there's plenty of screen real estate, but maybe for a phone app you want to have different, a different layout perhaps. So the idea would be you would keep C4 board and just come up with a new C4 display class. So the idea is you can reuse the smarts of the game and reskin it with other user interfaces, or you can keep the same user interface and put in, something that's even smarter. Change the class that implements the rules. So by keeping them separate, you can replace them independently of each other. That's the idea. Okay, so this C4 display object has a reference to the model. Yeah.
You didn't point out that in the real world, there's different programmers working on separate sections.
True. Right. You could be different groups of people working on the two sections, if you're able to split them up. If you can't split them up, you can't divide the work. Okay? So the rest of these instance variables so there's a move indicator class. That's a little circle at the top that lights up when it's, red's turn to play or yellow's turn to play. So in the GUI, I have a couple move indicators sitting around, and these are just references to them so I can change them when I need to. This is a label that keeps track of displays how many wins player 1 has, how many wins player 2 has, how many ties. And this board is the grid in the playing surface. So a common strategy is to create instance variables for the things that you need to change as the game progresses. Right? We're going to have to change the display of how many people have won. So we make that an instance variable so it can be accessed from different methods. So that's the representation. Let me pause here and see if there are any questions about either the choices of what things go into the representation, the instance variables, or what's going on up here where we're exploiting inheritance. Yeah?
So if you implemented something with more methods, would you need to redo all of those methods, or is it only the methods that haven't been completed?
You're talking about this extends JFrame here?
Well, no, for the implements action.
Yeah, you have to implement all of if you implemented an interface that had 4 methods, you have to implement all 4.
Well, I mean, but what if that interface had 1 or 2 methods that were already completed?
Well, until Java 8, there's no such thing as an interface having a completed method. Remember, interface just has declarations of headers. Now, it turns out in Java 8, you can put in an interface a default implementation of it. of a method, but we're not going to go there. Yeah?
What's the benefit of using like this implementation versus just putting in a method that does that?
Okay, of which implementation are you talking about?
Well, because you've had like the implements action lister, why wouldn't you just put the method in there? Why do you need the implements action?
Okay, so she's asking, I could just put an action perform method in my class and not bother with implementing the interface, right? That's what you're essentially saying. Okay? The reason is there's a method we're going to use down below that we need to give it as a parameter an action listener object. It's not enough to have the method in the class. We have to say we are an action listener object. Yeah?
I was wondering why you had variables for the number of times each player has won, because isn't that part of C4 board? Doesn't the board track that anyway?
Right, but these variables aren't for keeping track. I think I did say that, but they're just for displaying. So when we find out from C4 board that we need to display a new number of wins for red, that's just where we display them. Okay, so we got some instance variables. This is the constructor for C4 display. You know, we're setting the size. This, you know, you just tend to put that in all your GUI so that when you close the window, it closes the application. We're setting the title. We're laying stuff out. We've talked all about that. So this is just creating the objects, laying them out, making it visible. The only thing that doesn't have any, all of this is just GUI stuff except for this call right here. Well, this is, I've got to remember what board was. Yeah, we're just initializing the grid when you do that. So that's just, the constructor is what's responsible for that. Just setting up the initial look of the board. Okay? So then the rest of these methods are just needed. Occasionally, we find out from the C4 board class, the smarts of the game, that we need to make it's P1's turn to move. And it tells us that. This is how we do it. We set the color to whatever P1's color is. We set P1's indicator so that it shows up. We set P2's indicator so that it disappears. Okay? It's just a convenience method for us. So rather than have to do both of these things, we just call a method set P1 to move. Here's set P2 to move, which makes it change to the GUI. This clears. When the game is over, it's no one's turn to move, so we clear both indicators. This sets, you know, when we need to, we set how many wins there have been for P1, or how many wins there have been for P2, or how many ties there have been. Okay. Now, this is really the interesting thing. The rest of that stuff is very straightforward stuff. This says called when the new game button is clicked. So when the new game button is clicked, let's see what we're doing. We're telling the model. So I think of this class here, the display class, as being the view, what the user sees. The C4 board class you implemented is the model. It's the thing that knows about the game. So we call the new game method on the model and say, okay, we're starting to do whatever you have to do to start a new game. So we can, initialize itself for a new game. And then we tell the board, okay, do what you ever have to do to refresh because the model has changed. So every time we change the model, we want to refresh the board. Yeah?
Why do we have to add a board instance variable? Because when you use model's new game method, I think it's going to be automatically clear all the board stuff. Right?
Well, the model, all right, think about what model will do when it starts a new game. It will, internally, it will say, okay, I remove all the marks from the board. It's keeping track of where things have been placed. It'll clear the number of moves that have been made, various other things that has to be done. That by itself, the board doesn't know anything about the view, right? You implemented the board, did it? It didn't make any GUI calls. So it's this method right here, this refresh method is the one that now goes out and asks the board, what should I display? Yeah?
So like the model is how, like, the model is like how the game board works and the board is how the game board looks.
Yeah, the model is how the game works, the rules of the game. And what I'm calling a board right here is just what it looks like at any given point in time. Here's my question. Why is this thing called when the new game button is clicked? So there's a new game button. So if we go run this thing, there's a new game button right here. Why should that, what causes it to be called when the button is clicked? Yeah.
Because that's what buttons do. Buttons call the action performed.
Yeah, but how does that button know to call this method right here? Back there, yeah.
Is it the E?
Is it what?
Is it because you declared action an E?
No, when the method is called, a parameter is passed to it that tells you something about the action, you know, where it occurred, what time it occurred. Yeah?
You set an action event to that button up higher in the code.
Right, up here in the constructor, when we're setting things up, when we created the button, right here, there, we created the new game button right there. We changed its font. We changed its color. This is the key thing. We added an action listener. An action listener, when the button is clicked, any action listeners that have been added to the button are called via their action perform method. Yeah?
Something that's still kind of confuses me with the action listener thing is the use of this.
Okay. Well, what we're doing is we're saying when the button is clicked, call the action perform method of this.
That's the C4 display object.
Right. This is the object being constructed right now. We're in a constructor, so this refers to the C4 board, the C4 display object that's being constructed.
And that only has one action.
Well, right. Why is it okay to pass this as a parameter? It's because we say, it's not because it has an action perform method. It's because we say that it implements action listener. If we take that out, there are going to be several problems, but the one I want to look at right now is action listener complains. It says, you're sending me something that's not an action listener. This parameter right here has to be an action listener object. And it's only an action listener object if we come up here and say, yeah. So we're constructing a C4 display, which is a kind of action listener. So when we do this right here, we're saying when the button is clicked, call the action perform method on this C4 display object that's displayed right now. Now, what if we had two C4 display objects? What if I did this? Let's say, here. Suppose I just did this twice. Okay, so now I can run the game. Now there's two. They're independent games. What's going to happen when I click New Game over here? Is it going to wipe both boards clean? Okay, it's just going to wipe that one clean. This button wipes that one clean. How did it know which object to it? It's obviously calling the action perform method. How does it know which object's action perform method to call? Yeah?
That's what the keyword this does. It's talking about the object which is that specific for.
Right. We said when the button is clicked on this object, call the action perform method on this object. This refers to the object being constructed. So when I changed the code to create two boards, they each had a constructor run, and this constructor registered the object being constructed as the action listener, with the action listener, and similarly over here. So we use interfaces a lot in GUI so that we can find out about events. Find out when the mouse is clicked. You can find out when the mouse enters, when the mouse leaves. You can find out how fast the mouse is moving. And there are lots of other events that you find about. When is a button clicked? When is a menu pulled down? Okay. Now, let's go back. Up here we're laying things out. Here's the center portion. I want to point this out too. We're using a border layout so that when we resize the board, the extra space that's needed the extra space that's available goes to the center, which is the board. So we add the board to the center of the group panel. And, you know, well, for that call to work, what type of thing does that board object have to be? You can't add any old thing. Root is a JPanel. You can't add any old thing to a JPanel. Yeah?
Does it have to be another JPanel or JFrame?
Well, let's just see. I'll hover the mouse here, and it says it wants a component. Okay? So, for example, we could not add this there, because I don't think this is a... No, this is a component. Never mind. How did board get to be a component? Board is... That's a class I created. Board. How does it get to be a component? Why can we pass it to add? Yeah?
Didn't board extend JFrame as well, or JPanel, and JPanel objects are also component objects?
Let's scroll down here. That's exactly right. Board extends JPanel. And a JPanel is a kind of component. JPanel extends component. So this right here, when we said board extends JPanel, that made it so a board object is also a JPanel object. And it made it so that we could add it to another JPanel. And not only that, it implements MouseListener. Now, why do we need a MouseListener? Yeah?
To be able to, like, so the user can interact with the panel using those.
Yeah, but so that the user can interact with the, you know, the user's going to be clicking around on the board. And that's so we can find out when the button, when the board has been clicked on. Okay? So let's look at the constructor here. The constructor takes in a model object and a display object. So it gets a reference to the smarts of the game, and it gets a reference to the top level GUI. And we save both of those in instance variables here. Then we set some colors. And what's going on here? What's happening right there? Yeah.
Well, for every row you're creating like J number of columns, and then you do that in J number of rows, and so you're just putting a square in every single space.
All right. So it's just a look. It's just filling in. You know, we got to put 42 squares into the grid. Notice we create a grid layout that's shaped by rows and columns. We're just adding square objects. So we go in that loop, inside that loop, we create a square object, and we here's where we create the square object, and here's where we add it to the board. What's going on right here? Yeah?
You're adding a mouse listener to whatever square you just made so that it can hear.
Okay. So we're making it so that when one of these squares is clicked, this board object finds out about it. So rather than the square dealing with the fact that it's been clicked, we're having the board deal with the fact that one of its squares has been clicked. So there are 42 squares being created. Each of them has we're giving each of them a mouse listener, which is the board object here. So when something is clicked in one of those squares, the board object itself will find out about it. That's what we're doing. Okay. So that's board. Here's refresh. Now the job of refresh, you can see refresh is a display. This should be called whenever something changes in the model. So basically refresh just takes care of there are these methods in the model that will say how many wins have there been. You find out how many wins there have been, you set the win label appropriately. How many losses have there been, you set the loss label, you set the tie label. You go and ask it which squares should contain red, which squares should contain yellow, and you do that appropriately. So this method is just updating the display to reflect what the model already knows. Yeah?
What's the components array?
Okay? What's the components array? So you know, to be added, remember, this object here we're building is a JPanel. And the things that when you add something to a JPanel, it has to be a component. This is just the array of all the things that have been added to the board, which will just be an array of squares, square objects. Those are the things that make up the JPanel. And what we're doing is we're iterating through each square and asking the model what color should it be, setting its color. This is all, it's under the control of this code. But the way it works is just ask the model what color should this be, then it makes it the right color. So that, the highlighted code is setting the color of the squares. This, you know, you can see here, this is where we update the win and tie counts. And then repaint is not defined anywhere in here. I don't have a method called repaint. So why am I able to call it? Why can't I call a repaint method if I didn't define one? Yeah?
Does JPanel have a method called?
Right. JPanel has a method called repaint. It just says, okay, you can set the colors of stuff all you want, but it won't be displayed until you call repaint. So that just forces the GUI to repaint itself. And that's the method we inherited, because we're a JPanel. Okay? Now, to be a mouse listener, you have to implement a method called MouseClick, a method called MousePress, a method called MouseReleased, MouseEntered, and MouseExited. So essentially, when a mouse enters a square, it'll call MouseEntered. When it leaves, it'll call MouseExited. When you press the button down, it'll call MousePress. I'm ignoring almost all the events. If I'm told some square was clicked, I don't do anything. If I'm told some square, the mouse was released over it, I don't care. When it enters, I don't care. When it exits, I don't care. All I care about is when the mouse is pressed in the first place. Yeah?
So these methods are coming from the mouse listener?
These methods are being called because we registered the board object as a mouse listener for all 42 squares. Yeah?
What's the difference between MouseClick and MousePress?
MouseClick is press release. Press is just the press part. Released is the release part. So if I click the mouse, it'll generate a mouse pressed, a mouse released, and a mouse clicked. Now you may be wondering, why did I implement? You know, most of these implementations are empty because I don't care to do anything. I don't do anything special when the mouse enters. I could highlight the thing when the mouse entered the square. Why do you think I did mouse press as the? Basically, when you do the mouse pressed, that's the defining moment when you've picked where you're making a move. Yeah.
It says, is it faster than mouse click?
He says, is it faster than mouse clicked? Well, it happens sooner. Yeah.
Does the mouse click include the press and release? So you could press somewhere and release somewhere else?
Yes, and that's the problem I had. Was last time I implemented this, I did it on mouse click. But when I was playing with the game earlier this semester, I was trying to quickly click all through the board. And the problem is if you click the mouse and then move it out of the square and then release it, it doesn't register as a click. So I'm sorry, if you depress the mouse, move it and release it, it doesn't register as a click. And I was moving the mouse as I was clicking and nothing was happening because I was moving it too fast. So I just changed it so that just depressing the mouse triggers it. Yeah.
Something I discovered about MousePress, if you're using a mouse pad and you hover over one of the squares, it'll trigger as a press because it sees that as a press.
Okay, so maybe that was a bad decision. Right.
Can you repeat that on the?
Okay, what he said was, because I use mouse press instead of mouse click, I'm going to turn off my mouse here. So now I'm using the mouse pad.
Oh, no.
So, we're using a Mac?
No.
Okay. Well, what he was saying was that when he hovers it on his computer, it registers as a press. But now I'm going to turn the mouse back on. Sounds like a false loop. Okay. So anyway, so why do we have to implement these methods, even though we don't want to do anything? Yeah?
Would it be a proper mouse listener's object?
Right.
If
Mouse listener has to, it's its obligation to implement those methods. So actually, when they went to Java 8, as I mentioned, they added the ability to put default implementations in an interface. And so, for example, a sensible thing to do in the mouse listener class would be to put implementations on all these methods that are just empty, that do nothing. Then you just have to override the ones that you care to change. Yep?
Is there any difference between mouse listener and action listener? Can we say that mouse listener can inherit action listener?
Okay, so he's asking about the difference between a mouse listener object and an action listener object. And they're very different, right? Action listener only lists one method, which is action performed. Mouse listener expects 5 methods, all with different names. So there's no relationship between the two. You can't use one in place of the other. Action listener you typically use to listen to when buttons are clicked or when a menu is selected. Whereas mouse listener gives you very low-level information about the motion of the mouse. Yeah?
Do interfaces have instance variables?
Say again?
Do interfaces have instance variables?
Do interfaces have instance variables? No. They can contain constants, but they don't have instance variables. Now, let me just show you something. Here's mouse enter. Let's just do this. So let's just implement mouse enter. So whenever the mouse enters a square, it'll display the event E. The event E has information in it, by the way. E dot, you can find out the X and Y coordinates of the mouse. You can find out which modifiers were pressed. So is the shift key pressed? Is the meta key pressed? Is the Windows key pressed? And so on. So let's just do this. Let's do E dot get X. Let's just do E dot get X. So what's going to happen now when I run the program? What's going to change about the behavior of this program? Yeah?
Every time a mouse passes over the square, the X coordinate of your mouse will come to the console.
Right. So watch the console. So here I'm going to run the thing. Let me kill the old one. I will run the thing. Put it over here. Resized it for me. And just move this over here. So you can see as I move the mouse, every time the mouse enters a new square, it tells me the X coordinate where the mouse entered the square. So you could write your program to react to mouse, that kind of event. Now look at one more thing, then we'll take a break. Take this out. Let's look at this listener right here. This is what's called whenever a square is entered, this thing finds out about it. So what's happening here? So some square, the mouse was pressed in some square, and so this listener is finding out about it. Yeah. I got a better idea. Let's take a break and then we'll find out what's happening. So, take a few minutes off. With the CPM? Yeah, I wouldn't be surprised. So, yeah. Okay. Okay, so I was asking you what's going on right here. So who has an idea of what's happening? So the mouse has been pressed on some square. And since this board is an action listener for that square, we're told that the mouse has been pressed. What's going on?
Is it getting what squares being clicked?
All right, so get E dot, so E is the actual event. E dot get source tells you, let's see what it returns. It returns an object. So it tells you the object that was clicked on. Yeah?
And then you're casting it to a square.
Right. We know that the object that was clicked on has to be a square. Because why? How do we know it's not something that's not a square? Yeah.
Because there's only squares in the board.
Right. We only registered ourselves as a mouse listener for square objects. So it has to be a square. So this is called a cast. And basically when you have, the compiler can't tell that this is going to be a square. But we have inside information because we wrote the program. We know it's going to be a square. And so we say, okay, this is an object. We happen to know it's also a square, so we cast it to square. And as a result, it can be stored in the square variable. Okay? Now, what if it's not a square? What if we made a mistake and it's not a square? Who knows what would happen here? Yeah. It'd throw an exception. Class cast exception. But in this case, we're safe. Object, by the way, this says this returns object with a capital O. That's the thing at the root of the inheritance hierarchy. So every class ultimately extends object. Either, if you don't say what class you're extending, you're implicitly extending the object class. So everything is an object. Yeah.
Why do we need to cast that to a square?
Okay, why do we need to cast it to a square? Because the first thing we do is we call the get call method on S. And if all we knew is that S is an object, objects don't have get call methods, only squares do.
But since we know that everything's a square.
We know that, but the compiler doesn't. Okay? So if we don't do the cast, if we just do this, we say object S equals E dot get source. That's fine. Get source, the thing that was clicked was some sort of object. It's not going to let us call a get call method on some sort of object. As far as the compiler is concerned, this could be an array list for all it knows. It's not going to let us call get call. So we have to tell it. By the way, I'm sure this is a square. And it checks. And if we're wrong, it throws an exception. If we're right, it lets us treat it as a square. So anyway, we find out what column that square was in. So every square knows what column it was in. And we tell the model, by the way, someone just clicked in column 3. And then we refresh. Okay, so every time something is clicked, we tell the model something has changed and we refresh the display. All right, so the process of writing a GUI is essentially getting the stuff you want on the screen, laying it out in a pleasing fashion, and then handling events that you care about. You got to code what happens when this button is clicked, what happens when this square is clicked. And speaking of squares, here's the square class. So the square class is a kind of JPanel. So remember, on the board here, there are 42 squares. Each of these circles and a little bit of the blue space that surrounds it is a square. And so every square knows what row it's on, and what column it's on, and what color it is. And the reason it knows is because here's the constructor. When you create a square, you tell it what row and column it's on, and its color starts out being the same as the background color. And then let's see what a square can do. You can ask the square what row it's on, you can ask the square what column it's on, you can tell a square what color it is. And this is the important thing. What's happening right there? Yeah?
It paints the individual square.
Right. So paint component is a method that every component has a paint component method. And that controls every time that Java decides to repaint things, to refresh things, that's what draws the square. So what we're doing is we're overriding, we're throwing away the implementation that existed for paint component and replacing it with our own implementation to do something different. So we're customizing. We didn't have this. If I comment this out, actually that's the wrong thing to do. This overrides it as well to do nothing. That's not what I want to do. Let's just comment the whole thing out. Suppose I didn't override the method at all. What would change about my implementation? When I run the game, what's going to happen? Okay? And I can click, stuff's happening, but I can't see it. Because all these squares are being displayed the way JPanels are displayed by default, which is it just displays a background color of some kind. It's only by overriding, by replacing the paint component method with one that does what we want it to do, that we actually see the squares, and they change color when they're clicked. So look what happens. When Java decides to paint a component, it gives you the graphics context to paint it on. And this call right here is a bunch of gobbledygook that just makes the graphics look better, sharper. We set the color to whatever the board color is. We fill the entire square with that board color, the blue. Then we set the color to whatever color the square is supposed to have, the circle is supposed to have, and then we fill that circle with color. We just do a little bit of graphics operations. And that's called automatically for us. And it all happens for free because we're overriding paint component. None of our code calls paint component. The Java Swing package decides when it's time to repaint a piece of the screen and calls these methods for us automatically. We just have to say what to do when it is called. That's the power of object-oriented programming. We don't have to understand anything much about the larger scheme of things, how these GUIs are controlled by Java. We just have to know that if you want to customize how a panel is painted, you override the paint component method. Okay? What if we wanted the circle to be smaller? All right? When I run it, the circles are that size, those gray circles. What if I wanted them to be smaller? What would I do? What do you suppose I'd have to change? Yeah. Right, this is the, so fill oval, we give the x coordinate, the y coordinate, the width, and the height. So I could say, okay, let's just make the width smaller. Well, I'll divide the width by 2 and the height by 2. So that's be kind of weird looking. I'm smucking around with how things are colored. So now that's how it looks.
Play it.
Okay, so that doesn't look as good. And that's just because I changed the height and the width of the thing. All right, so I just want to emphasize where we used polymorphism here. Everywhere we implemented an interface, well, all three of these classes we've looked at extend something. So that's inheritance. Here, we inherited all these methods from JPanel. We actually replaced the implementation of one to do some custom work. These other classes up here, they each extended something. This one extended JPanel, but it also implements Action Listener, which makes it so that the JPanel can behave as an Action Listener and be rigged to find out when a button is clicked. So you may do similar sorts of things in your implementation. Okay, so let me see any last questions I could answer.
One thing, so earlier you mentioned that the GUI is not related, because they're in different classes, the GUI and the actual actions of the game are separate.
Right.
So technically when you had it kind of blind where you couldn't see what was happening, it was still placing the pieces and you still technically could play the game, you just can't see what's happening.
Right, right. So that's a good thing to look at. We're not changing anything about the model. When I come here and I comment out this overridden method so that it uses the default version, it's still finding out when squares are clicked in. It's still telling the model when columns are clicked in. It's still figuring out, can't be right. Oh, this is yet another class of overridden. It's the little indicators at the top. So let's move up to the actual class here. That's the move indicator class, which is another one I did. It's this one I need to get rid of. We'll play the game. We can play the game, but we're sort of playing blind. So let me see. I'm going to click for red in this column. I'm going to click yellow over here. I'm going to click red over here, yellow over here. Red over here, yellow over here. So right now I've got 3 reds on the left, 3 yellows on the right. So this ought to win the game when I click here. Red wins. So the game's still playing. It's just not showing because we killed the graphics. Yeah?
You specifically have to put at override to override the default.
Okay, so that's a good question. This at override is optional. Okay, but I recommend that you use it because, all right, let's say, let me put it back in. If I say I'm overriding the paint component method, but let's say I left the E out, it's going to tell you there's no method named that. You can't be overriding the method. But if I don't claim to be overriding it, I may not notice the misspelling. If I don't put override in, though, it still works, assuming I spell everything right. So the game will work properly. Still works. I have overridden the method. It's just, it's better to do that so you find out about typos and such. So just get in the habit of doing that. Okay, if there are no other questions, I'm going to move on to a different example. I'll give you, you'll be doing this stuff for a week, yeah.
So I guess another question. Earlier you made the graphics smaller. What if you made them so big they start overlapping each other?
Okay, so he's asking, what if I made the graphics bigger? So rather, let's say I did it, now. Let's just make it a lot bigger. So let's see what happens when I make them so big they're going to interfere with each other. Okay? So obviously I made them so that they were sort of this big. But the way the algorithm for redisplaying works is swing, that's the package we're using in Java. Swing knows how big each of these squares is. It won't let them draw outside of their area. So it's clipping the circle I'm trying to draw. So, the game will still work. It's just a different effect. So you can only, no matter how big you make, you're restricted to drawing in the region of the graphics where you are. Yeah.
So each square is like the blue border with the gray circle inside it?
Yeah.
Okay, I thought it was like there was just a huge blue rectangle with a bunch of holes in it.
Right, so yeah, when I click here, I'm clicking on the square, even though I'm clicking outside the circle. And the reason that works, so border is a constant, it's 5. So essentially when it draws it, it's not drawing the circle to, the circle, you know, you'll notice the circles don't touch. They're separated out a little bit, and that's because of that border offset I'm using. Any other questions I could answer? Yeah?
And the reason it's gray is because you put gray in the middle, it's just hollow in the middle, and then when you click on it, it becomes red.
It's gray because when an unoccupied square is clicked, it uses the background color to color, which is gray. Right? So if I change this, make the background color be pink, and I run it, and now it's pink. That's the advantage of defining constants that's used throughout. I didn't have to go search and find everywhere there was a gray and change it to pink. I'm using background color throughout, so I just had to change it in one place. You know, if I want to make, I could make the border, let me make border 0 now. So I'll make border 0 and run it. Then it's making the circles as big as it can and still fit the square, and that doesn't look too good. They're sort of touching. So that the border controls that. Right? I can make the font size smaller. Now you can't really read that stuff up there. What other questions can I answer? Yeah.
Would you say then that a good point, like a good starting point for the new project would be like copying this and switch it to how you need it?
If I were you, I would start with this project. And the first thing I would do is modify the C4 board. I've changed the names, you know. First thing I do is refactor, change the names of things to make more sense. C4 display is probably not so good. We call it lights out display or just display. And then I would modify the display class until the thing looks like I want it to look, until it looks like a lights out board. And then I would work on the model so that it plays lights out outside of Connect 4, and then I would have wire up the events to communicate back and forth. Yeah.
Is there a way to like maintain proportionality of your squares, regardless of how many rows or columns you use? Because right now you have your height is 600, or your width is 600, your height is 600 too. Mm-hmm. Then you have 6 rows, 6 columns, and the way you have it, that gives you nice circles and squares. But if you change your rows to like 10, it's going to squish everything. Is there a way to?
Well, yeah. I mean, you could set the width and the height as functions of rows and columns.
Okay.
Right. So I could define rows and columns first, and I could say width is 6 times rows and height, or width is 100 times rows and height is 100 times columns minus 1 or something. But the thing to realize is, no matter how big you make it to start with, the user can screw up your intentions.
Right.
And although we could probably solve this as well, I think there's a way to make it so you can't.
Right. If you set resizable to false.
Yeah. Make it so it's not resizable. Okay. Yeah. Yeah. We could do more here to make it look a little better. Having these numbers depend on these numbers. Yeah.
Okay.
What other questions? Yeah.
Why are you making your own color instead of using the default red for V1 color?
Oh, all right. So I'm using, all right, that's a fair question. Let's see what it looks like. Okay, so this was sort of my cobbled together. It's a less intense red. If this was 255, and this is the red number. So no blue, no green.
Could you repeat the question?
Question is, why didn't I just say color.red? Why did I make a custom color? Okay, so now someone tell me, why did I not use red? Doesn't look too bad up there. But on my screen, I have a hard time reading winds, for example, because the red on the gray background is just too intense. It almost is like shimmering. So I just couldn't stand to look at it. So I tuned down the red a little bit to please me. But the projector, yeah, it's fine on the projector, but not on this monitor. Yeah?
Does your dialogues method have a close button thing, like on exit? Like you know how like every interface has got that little thing at the beginning where it's like, if you click X, close the window?
So you're talking about this X up here?
I'm talking about from like a project from like PS4 or something like that, where we use the dialogues class of this. So does that have a close statement, or just curious?
Well,
repeat the question.
Okay, so he's asking about when we use like my dialogues class that had like show message dialogue, such. Okay, so those classes were implemented using stuff that's built into Java, namely there's this class called JPanel that provides an method called show option dialogue, or show message dialogue, and show input dialogue. And so I inherited all that functionality from there. So I'm not sure if I'm answering your question, but I didn't have to do anything special to get the X's to work. Okay. Yeah?
I'm just not sure what things JFrame and JPanel do, like the difference between them, like when. Okay,
a JPanel is a top-level window. And a JPanel contains, among other things, actually more complicated than a JFrame rather. Okay, back up. JFrame is a top-level window. A JFrame contains a JPanel, and it's called the root pane. So all this stuff from, that I'm controlling, from this gray bar at the top all the way to the button at the bottom, that's a single JPanel that contains what I want to display. Now, what else is there about this JFrame that distinguishes it from a JPanel? What does that JFrame have in addition to what I just mentioned? Yeah.
It has 3 components.
3 components? Well, the top-level JPanel has 3 components. So the JPanel that's inside the JFrame has that bar at the top, and it has the grid, and it has the button. But what about, yeah?
It has the exit, the minimize, and the
Right, it has this stuff at the top. Okay? So a JFrame is designed, it's just a top-level window, and it has a title at the top, and it has this icon right here, and it has, it can be resized, it can be iconified, and it can be X'd out of. You can also add, see if I can remember how, C4 display, let's do this. It has a method called set menu bar. All right. Yeah. So we could create a menu bar and add it to it. First, we'd have to create a menu bar. We say something like J menu bar. And set menu, then we would say, we would add bar. It's been too long since I've done it. Create the menu bar. Okay, I give up. But anyway, you could create a menu at the top. You could have like a file menu that closed it or saved the state of the game, or an edit menu with copy and paste. So you would just create the Set JMenu bar. Okay, and then let's finally do this. Bar.add. Okay. Great. So this is a JFrame. You can't add menus to JPanels, but you can to JFrame. So I run it. And now I get a menu bar here. I get the file menu. Now nothing happens. I need to add more stuff so that something appears when I click on file. And I had to add event listeners to tell when menus have been clicked so that you do something. But that's something else you can do with the JFrame that you can't do with a JPanel. Yep.
So I see that is placed in another row. So is there any way I can place the file in the first row with the big frame?
You want to put the file menu where?
Upper.
Oh, up there where it says Connect 4?
Yes.
I suppose if you'd have to override the default behavior of JFrame.
Okay.
You might be able to do that, but I'm just letting it, by default it puts it where I showed it right there. Yeah?
On our side, do we need, when we have like a create mode, if it's not solvable, do we need to tell them it's not solvable, or is that not something we need to worry about?
That's nothing you need to worry about. So, people that have TA'd this class before, like Stefan, have learned how to, have become experts at solving the game. So, you remember how to do that? So when they're grading, they got to find out, when you create the initial position, it has to be solvable. And he can judge that because he knows how to solve it really fast. So if you'd like to learn how to play the game, Stefan can teach you. Yeah?
So like, instead of just having, because at the moment my object, it just randomly selects squares out of the number of squares that exist to turn the lights on for the beginning of the game. Is there like certain patterns I need to have?
Well, okay, so if you take a lights out board and randomly pick squares to turn on, you'll almost certainly create a board that can't be solved. To create a random initial position, what you got to do is start with a blank board and then just simulate a game. You pick a square at random and pretend like you're clicking it. All right? So now imagine you picked a square at random and clicked. So now you've lit up 5 squares.
Yeah.
If you click that again, you would have solved the game.
Yeah.
So just imagine taking a square board and clicking at random, a blank board and clicking at random. Wherever you end up is going to be solvable just by reversing the order in which you clicked everything. So just do that virtually when you create the board. Simulate a game. Simulate a random game of a random length. Okay? All right, well, we will continue not with this, but with more polymorphism next time.